It will be from the house of Sultan Chand and Method AI. The welcome will be.
Yes. I am admitting some participants, sir.
Yeah. Good afternoon, everyone. The House of Sultan Chand Sons Private Limited and Method AI, the AI learning platform, extend a warm welcome to all the participants to this data science webinar. It feels nice to have you all here, and we thank you for that. A bit about the house first. We are pioneers in the field of book publishing in post-independence India, catering to students from pre-primary to university level, churning out over 600 regular titles besides adding new ones to our stable year after year. Known for competently written, elegantly produced, and reasonably priced books, our publications are widely prescribed in reputed schools, colleges across the nation, as well as in some neighboring countries. Our authors are distinguished academicians, professors, and educationists with vast experience and expertise. We are proud to be associated with them. Allow me to introduce to you the host of today's webinar, Dr. Sachin Gupta. Besides being the author of 2 data science books for classes 9th and 10th, he is also Dean Academics and Research and Professor in the Department of Computer Science Engineering at MVNU for the past 7 years. He has also been HOD Computer Science Engineering and MCA Department in Dronacharya Group of Institutions, Deputy Director and Head of the Computer Science Department in Chandra Prabhu Jain College of Higher Studies, affiliated to GGS IPU, Delhi. With a teaching experience of over 20 years, which includes teaching undergraduate and postgraduate students and researchers, Dr. Gupta's academic pursuits have been fairly meritorious, winning him several awards, distinctions, scholarships, including the Certificate of Academic Excellence by GGS IPU. Dr. Gupta has also contributed to various journals, conferences, and books for schools and higher education, both nationally and internationally. His achievements are commendable. Let's give him a big hand. May I now request the man himself to take you through today's session, Dr. Sachin Gupta. Have a great day ahead. Thank you.
Thank you for a kind words, officer. Okay, this is for the faculty and the students, for those who are looking for a career in AI, statistics, and data science. So I'll start with a very quick question. How many of you are actually familiar with the role of statistics in data science? We can use the chat window. We can just start the raise of show of hands. Okay, so I'll assume with absolutely zero knowledge of topic, and let me begin. So greetings to all the faculty and the students who are joining here. I am Professor Sachin Gupta. I work as the Dean of Academics at MVN University, and I am a product consultant to Method AI for A&DS. I've been struggling for technology teaching since 20 years, and I've just authored a book series on essentials of data science, which is coming up as a subject in 2023. So why is statistics important is a very obvious question that most of the people know. Statistics is important. And in this session, we are going to understand the benefits of having a strong background in stats as a data scientist, as your students would require. We'll start with a small quote like, data is a faint light when you are lost in dark room. If you follow it, if you try to make sense of it, you might actually know where you are and what is around you. The basic problem solving in statistics starts with an investigative question, that what are we trying to solve, or what are we trying to register from the data. Then we have to actually look for collecting data. Is there some variability? Can we solve the problem with data or not? Then we analyze the data through statistical methods, and we present the interpretation based on the analysis with visualizations, with some results, with some statistical tools that we are actually looking forward to work with. This is the usual statistical problem solving method. And looking at the data science process, it would be more like a collection of data, cleaning of data, exploratory data analysis, model building, model deployment, and part of it, which is related with collection and cleaning of data, that is associated with data engineers. Then data analysts actually work with cleaning and exploratory data analysis. And there is a completely different branch of people who work as machine learning engineers, who are associated with model building and model deployment. Together, all of them can be called as data scientists. So what are the approaches in data science, not particular to statistics? We follow the OSEMN model, which actually speaks about obtaining data, scrubbing it clean, exploring data, modeling it, and finally interpreting the results. Looking at the previous two slides, the first was investigation, collecting data, analyzing and interpreting data. We may be actually able to say that is statistics equal to data science? That how many of you agree that statistics is almost equivalent to data science? Can we have in from the participants? Okay, Stuti says not completely, but yes. Anybody else? What would be the difference if we are to actually think the statistics and data science are somehow going to be different? Okay, let me illustrate. How much data did you generate today? Let's have a look. I'll keep the chat window open so that anybody else who wants to speak up. So in a minute, people send 16 million texts. The Facebook users share 1.7 million pieces of content. On Google, there are 5.9 million searches happening. On email, there are 231.4 million messages being sent. On Instagram, there are 66,000 photos. On Twitter, there are 347.2 thousand tweets. On Snapchat, there are 2.43 million snaps. And there is a lot.
Thank you for seeing us at such short notice, Miss Slater.
And as well, Bill prints have been hacked.
Derek Gates wasn't.
Okay. So information is the oil of 21st century and analytics the combustion engine. Let us go back to my previous slide. With pure statistics, it was very difficult to actually analyze this data. Right. Let me go back to a slide prior. With statistics, we were actually working with collection of data, analyzing and interpreting it. It works for a small amount of data. That means you must be very familiar with that. We were looking forward to populations, and from populations, we are taking some sample out. From the samples, we actually try to find out some analysis. So we don't, even in statistical data analysis, we don't actually take the complete data. We take a portion of the data that we call as a sample to work with it. And looking at what we are having now, we see there is a huge amount of data that is being generated per minute. And this is actually very difficult to analyze with pure statistical methods alone. But fortunately, with data science came in a lot of things, like we now have access to programs which are analyzing my data automatically. You think about AI, you think about machine learning. They are actually allowing you to find patterns from data without actually having to work with data as well. Right? Similarly, there is another thing that we actually can work with, that is it possible not to even write a program and still be able to analyze the data? That is, yes, again, that is a machine learning thing that we actually try to do. Now, if there is an abundance of data which was not there earlier, statistics actually fails, pure statistics, because we need to be a programmer now. We also need to be an analyst. We also need to understand how is data collection, data cleaning, and everything that clubbed together. So where statistics was failing because the huge amount of data was being generated, data science actually steps in. It allows us to use the best of computing methods to make sure that the statistics also stays relevant. So that is how data science helps statistics. But how statistics is now going to help data science, that's going to be another picture. So in any artificial intelligence product, there would be a life cycle that you would see, that it almost starts as the same as a statistic problem. You understand the problem, you gather the data, explore it. If it is a supervisory problem, you may be actually labeling the data as well. Then you wrangle the data, prepare it for analysis and so forth. Then you create a model, evaluate it, and then eventually move it to production. Now, statistics applies to almost all of the parts here. How do you understand the problem? How do you gather the data and explore it? Then how do you model the data and evaluate it? All of them have to do something with statistics. Vikrant Kapoor says DS data is too large, stats have very little. Absolutely right, Vikrant. This is the basic reason how statistics and data science are actually helping each other out, because pure statistics would not have been able to work with this large amount of data, and data science would not be able to work without statistics, as we will see just in a very short while. So why statistics matters in any data science problem, just look at it. Whenever we are actually having a large amount of data, we need to explore the data. We need to understand what kind of data do I have. We need to see that, is my data having a lot of variables which are related to each other? Are the variables not related to each other? Are the variables contributing to my problem statement? There may be some variables which are just extraneous, which are not contributing. We need to see the size of the data, the quantity, the accuracy. We need to understand the nature of the data. That is one part where statistics comes into picture. So going back into understanding of the problem, I will not be able to understand the problem of artificial intelligence unless and until I actually go into visualizing and exploring the data a bit. Then again, statistical analysis technique can help us see that out of the large amount of data, which portion of the data is useful with a few metrics that data science allows us to check. Then statistics in data science finds its roots in the structure and relation between various unstructured data. So earlier, when we were working with statistics, pure statistics, our data could be structured our data could be in the form of tables. We would usually know what the variables were, and we would know what was the relationship between the variables. But data science per se, it even helps with working with unstructured data where we do not know what is the correlation happening between the various columns, or then columns may not even be present. So that portion is actually helped with by data science. So data science helps statistics in this manner, that whenever we are actually not aware of what is the structure of data, there, if there is a good correlation between two columns of unstructured data, we can actually use one of them. So if you want to have valuable insights behind your collected data, there statistics comes into picture. Secondly, the data analyst must understand, establish a comprehensive picture of the data before collecting it. Like, I may not want to actually go around collecting the data from all the parts of the world before I actually have a small sample. I want to collect the data for people coming in into, let us say, the state of Delhi. So I'm actually trying to find out what are the food habits of, let us say, the youth in Delhi. From Delhi, I may actually want to take it to all over India. From all over India, I may want to take it to all over the world. But statistical analysis for a small sample of youths in Delhi, that may actually allow me to understand how I can actually extrapolate this to the entire world. I might not have the means or the budget to actually explore the entire world, but I would still be able to tell that is the data collected for one small portion of sample of population is statistically significant that can be applied to all the other people also. Okay, so there is a quick question that I am going to take. Arjun says, what is inferential statistics? Okay, inferential statistics is about that, can you infer or can you draw some information from the data? So there are two types of statistics that we talk about. One is descriptive. Descriptive statistics deals with that, can we describe the data? Would we be able to actually tell, let's go back to see. So if you are actually looking at the data, there is something that we call as exploratory data analysis, right? So you see a comprehensive picture of data, like whether the data is bivariate or univariate or multivariate, what are the principal components of the data, or what are the portions of the data, what is the mean of the data, what is the median, how many rows and columns are populated, which rows and columns are empty, which rows and columns can be dropped. That basically deals with exploratory data analysis, and that is the descriptive, that what are the properties of data. Inferential statistics usually deals with that, what insights can we gain from data, that given that let us say that gold is actually increasing at a steady rate, that last year the gold prices was some amount, last to last year there was a 10% less price, and if we can say there is a 5 or 6% increase in gold every year, then the projected value of gold in 20 years from now, that we can calculate on the basis of inferencing from past data, we are actually trying to predict the future. So that basically inferential statistics deals with that, using the large amount of data that we have collected over some phenomena, that data we actually use to predict some value that may happen in the future. That portion is inferential statistics. Going back to my presentation again. So why statistics matters again, many machine learning performance measurements such as precision, accuracy, recall, or RMS, F-score, all of them are based on statistics. Okay. So these parameters for evaluating whether my model which we have created, they are actually good enough or not, that basically deals with statistical processes. Right. So think of data science as the process of cooking. Why statistics is again important. In the absence of that, see, any AI, any machine learning, any data science, any AI or ML particularly, say, not data science, data science would be something that is going to help us work with AI and ML. So let us consider if we want to work on the project of AI or ML. Any AI or ML project would be only as good as the kind of data that we are feeding to it. I mean, you feed it bad data, which is not good. or which is not statistically significant, your model is going to result in bad results. You give it very good data, your model is going to pick up from that, and it is going to give you very good results for prediction or for classification. That means if you tell, let us say your AI model is about classifying cats and dogs, and you keep on feeding it images of cats, it does not see any dogs. So any single or two pictures or three pictures of dog that it sees, it is going to still classify as a cat, because whatever it has seen, that was only cats. Worst case scenario, you don't even feed it any cats and dogs data. You are just simply trying to feed it data, which is, let us say, a raccoon or any other animal, a tiger, something like that. So in that case, a data science model or an artificial intelligence model, which is supposed to classify cats and dogs, it might even classify a tiger as a dog, because the only thing that you actually kept on telling your AI was that this tiger is a dog, this tiger is a dog. It's actually understanding this tiger is actually being labeled as a dog. So when my data is bad, my results are definitely going to be bad. So almost like cooking, where data science works. So let us try to analyze how we actually can relate data science or statistical modeling with finished product. So when a chef is starting out a new dish, he has to understand what the current menu is missing. That is your investigative question in statistics, right? Your ingredients are data. So you are supposed to gather ingredients from the market, maybe raw ingredients like vegetables, they may be spices, there may be any other ingredient that you want to cook with. And you are also gathering the ingredients for the data science using web scraping. That means your data may be available on the web. We are going to look at a case study here. The data may be structured query language coming from several data sets, but that data might not be actually readily usable. So first part where statistics helps you is that you may replace all the null values or wherever data is not available with the mean values. That means you are doing some feature engineering. You are cleaning the data. Wherever there are outliers, you might want to remove them. Wherever there are data values which are almost impossible to work with, you can simply remove. So eventually you do flavor engineering or feature engineering. That means you might put the data into portions for, or if your data is like two different parts, one data is in thousands, other data is in units, you might want to take the logarithm of the previous data so that they both match in the units and sizes. Then you try to see how the data elements work with each other, understand the profile of each ingredient, how they are likely to taste each other. You call this as exploratory data analysis in the terms of statistics. Understand the relationship between our variables, that how is one variable contributing to the other. Fine. After that comes the machine learning part, that you try to see what is the model that would you apply. It would be regression or classification of clustering, which one of the model works best. And then you do some tuning portion that actually goes into the domain of machine learning and AI. So that portion I'm skipping. But eventually you get some results out of whatever you have produced. You are getting some result because of the data that you have analyzed. Now, how are you going to make sure that the results which you have got, they are statistically significant? They are even accurate. Are they giving you some correct values or not? So that portion is something that we call as validation, right? Statistics helps you validate the results that you have given. That means you'd be able to get a result, but to find out that how accurate is it, are you getting 95% accurate results or 100% accurate results, or your accuracy is only 50%, that portion is also helped by statistics. All right. Let me take you to a quick summary of how the data science landscape is growing since the last couple of years. So the data science landscape actually deals with software engineering on one hand, where people work with model deployment, parallel computing, code optimization and all, web development. The data science landscape works with data pre-processing. This portion is completely statistical. So how do you obtain data? How do you handle the missing values, cleaning the data, engineering features as we discussed, and feature selection. This portion is completely based on statistics. Part of my data science landscape is mathematics, where there is a probability theory, optimization, and probability and optimization both actually relate to statistical methods. Besides, there are linear algebra, matrices, which are other portions of mathematics which actually work with statistical analysis of data. Then, over the years, data visualization has also gained importance, which had been traditionally a statistical field where you were looking at what are the different types of graphs that you are going to produce for presenting your results very well. That are you comparing values? Is it a composition like a pie chart? Is there a relationship existing between the data values, or is it a distribution? So all of them actually deal with statistical analysis again. Right. So you can see that the complete landscape of data analytics is working with this portion in statistics. There is a lot of portion from mathematics that's coming in statistics. There is a lot of visualization that is coming from statistics. Besides, in data science, we add in programming to make sure that whatever mathematical models we are working, they can be automated. All right. Then let us do a small data exercise to understand how we can actually look at data. We can collect the data, look at it through the picture of statistical modeling, and then we are going to actually take some questions on how you are working with this data. How many of you have heard of CODAP? We can have on the chat window. Okay, how many of you do eat at McDonald's? Just say that, just put a message there. Anybody? Okay, Nomita says they're McDonald's fan. How many of you have seen the McDonald's product page? Let me take you to that. Here is your McDonald's product page. So you'd be able to see for every product, what is the serve size, energy, protein, fat, trans fat, carbohydrate, sugar, dietary fiber, sodium, and there would be a complete detail for each of the product here about the nutrition. There is a lot of products McDonald's serves. There's the breakfast menu, some favorites, Happy Meals, and so forth. Do you see some data here? What is the data that I can see? Okay. There's no answer. I'm just going to show you what is the data that we are actually associating with it. So we are working on a platform called devcodap.methodai.com. You would be able to actually access this online. And I'm going to take an example for fast food nutrition here. We'll start from scratch. Now you see the data. For each of the products from McDonald's, from the breakfast menu, the item is Egg McMuffin or say bacon and cheese. There's a serving size, the calories from fat, total fat, saturated, then cholesterol, sodium, sugars, protein, everything. All right. How do you think we will be able to analyze this data by using data science? Let's check out. I'm just deploying a graph here. And okay, quick question to the audience. What do you think contributes most to the people getting fat by eating fast food? So your choices are like you can choose between fats, carbs, sugars, and protein. Which one of them contributes most to people getting fat? Okay, there's carbs, fat, sugars, fat. Interesting choices. Dilip says carbs. All right, we'll work with these. Rima says carbs. Good. Okay. So majority of the people are leaning towards carbs, but if I have to find out what is the fat contained in the products, let us look at that. So there's a total fat for all the products. And we are going to look at the calories. Those who understand the graph statistically, they can see that there is a high correlation existing between the calories and calories from fat. Can you see it? So the R square value or the residual squares value is 0.818. It would have been 1 for a perfect correlation. All right. Let us say plot a graph between calories versus calories from fat. So there's calories. And there is calories from fat. And you'll be able to see almost a similar correlation between them. All right. Although they are two different graphs, but most of the calories coming are calories from fat. Okay. Let us check out the protein carb ratio. So we'll create another graph from the top. There comes your protein. Here comes the carbohydrate. There's no correlation per se, right? But what if you have to choose which is the best category at McDonald's if you want to eat? Let us divide this. And select by category, calorie. So you see the data science in perspective here. I'm just changing the graph a bit. Okay. So what my graph says, am I audible still? All right. Okay. So looking at my graph, you'd be able to see where are calories going high to where are calories going low. So all the low calories are light pink, all the high calories are moving towards the dark. For the beef and pork, there is no low calorie product, although the carbs would be maximum 15, 51, but the protein in these are more. There is a lot of calories ranging between, let us select only these. Right. Let us hide the unselected cases. So this is only beef and pork. You see there is a carb to calorie ratio. There is, and we are actually, what did we miss? We missed the, well, which one is the lowest, least amount of calories based on these? Can you please check out the graph and let me know? I'm just saying that all the products having small amount of calories are light pink, and all the products having high amount of calories are dark pink. Out of all the categories, you have beef and pork, beverages, breakfast, chicken and fish, coffee and tea, desserts, salads, beverages, low calorie products. For me, it was a very easy thing. I just had to choose the first categorization. And actually, it shows me from the beverages, there are a lot. From the coffee and tea, there are a lot. From desserts, there are only a few. And from snacks and sides, there are a lot. But if I look at the high calorie content, check out. Beef and pork are usually associated with a high amount of calorie. Breakfast is the biggest culprit. So you see in breakfast, there are some products which are adding a lot of categories. Hot cakes, right? Then smoothies and shakes, they are yet another category of product which are actually loaded with calories, right? But would you be able to say that the smoothies and shakes are dependent upon carbohydrates? What do you say? It is sugar, carbohydrate, fats, or protein? Can you really say? My question is again, fat, carbs, sugars, and protein. There was one person who says carb, fats, and sugars, but rest were fat, carbs. Nobody. Let us try create another graph. And this time we are going to plot sugar against calories. What should be the correlation? Do you see there is a positive correlation happening between the sugar and the calorie? And if I actually look at, instead of sugars, I replace it with fat, the relationship becomes almost perfect. Right? So most of the people believe that carbs are the culprit for calories, but by and large, it is fat and sugars. Let us try to put in carbs also. So carbs to calories ratio is a lesser percentage than carbs versus fats. Okay. So there can be a lot of analysis happening between with the data values, right? But the essential point is that with statistical analysis, we just collected the data. We actually brought into a table. That data was possibly structured even before we started, because the McDonald's actually had made it structured. But in the worst case scenario, we might have had to collect the data from the sources and then convert it back into a table. The good point is, with data science, we are actually getting in tools which are allowing us to immediately consume the data, visualize it, draw inferences. Okay, so there was a question coming in from the meeting chat that actually said, what is inferential statistics? Here, Arjun, if we want to actually correlate that, what should I eat when I go out to McDonald's? If anybody wants to actually watch their weight, what should you be eating out of all the product categories? I'm giving you the graph back. So your categories are, okay, your fats are, sorry, calories. Okay. So on one hand, I have calories, and on the other hand, I am dividing them on the basis of category. Right? And then calories again. This would be the graph that we are actually interested in. Which products do you think should you consume when you are going out to McDonald's to eat, if you are watching your weight? Surprisingly, all desserts that McDonald's serves, they are almost low calorie, almost close to the salads. Can you believe that salads and desserts are the same in terms of calories? So this is the power of data science, which you would normally not be able to actually correlate. Most of the people would believe that desserts are going to be high calorie. But at McDonald's, they are the safest bet. If you want to eat beside beverages, they are all low calorie products. Desserts are all low calorie products. Coffee and tea is, a lot of products in coffee and tea are low calorie. What actually takes the most amount is breakfast, beef and pork, chicken and fish. They are the products which are actually adding in. Smoothies and shakes are the worst. Right. So this was about how do you analyze, collect, and show how statistics actually helps us looking into data science. Correct. I believe that we have time for some questions that we can squeeze in. Okay, so data summaries of thousands of stories. Tell a few of those stories to make the data meaningful. That basically is the purpose of statistics and data science both. I'm looking forward to any question that may come our way. We've got 15 minutes to go. Okay. I think there are no questions from the audience, so we will be able to close it. I have shared my mail IDs, both my university mail ID and the Method AI one. If in case there are any queries that you want to ask later, you can redirect them to me. I'll be very happy to answer. Thank you so much for joining.
Thank you, Dr. Gupta, for this interesting and informative session. Some data that you shared was an eye-opener for me also. I'm sure everyone enjoyed the session. Want to share a message with the teaching community and students. We'll be holding regular webinars on data science, details of which will be shared with you all well in advance. That's all for the day. Thank you.